Pittsburgh and University. This is JC on a Bike. My name is JC and this is Journal Club on a Bike. I'm going to cover a couple papers this afternoon, that are related to the current pandemic, the coronavirus outbreak. And specifically, I want to look at a couple papers that were recently released. One of them is a preprint, one of them is a recent publication, and just kind of give a shout out to these papers and what I think about them. So the first one is a funny one that's been circulating the internet lately because it has a very interesting potential conclusion that it puts forth, the hypothesis that it puts forth. In this paper, the author points out that there is an extreme deficiency in CpG dinucleotide repeats. What these are sequences in the genome of viruses that our own cellular machinery used to recognize foreign DNA and target it for destruction. And so, interestingly enough, in this paper, the posit is that SARS-CoV-2 has an unusually small number of these sequences, and he suggests that this means that maybe the SARS virus that we're currently experiencing was enriched in a tissue type or a host that is expressing a high number of the proteins that target these sequences to eliminate viral genomes. So essentially what he means is that in animals that have a great expression of ZAP proteins, these are zinc associated proteins that are involved in the degradation of viral DNA. These proteins are expressed differentially in different tissue types and preferentially in different animal types. And so you could make the argument, or this guy would make the argument, that the extreme deficiency in these small CpG repeats, CpGs, these dinucleotide sequences, these are missing from this virus, and it might indicate or give us a clue of what host it passed through. So then what he does is he shows you that none of the bat viruses have this. None of them do. And then he gives you some sort of, it's not anecdotal data, but it's just data that shows that these repeats are especially missing from canine viruses, dog viruses. Now, to make the jump from the presence or absence or relative abundance of these CpG sequences as a way of tracing it back to canine passage, I think is a bit of a stretch, but again, I'm not a virologist, so he could be making a stronger argument than I anticipate. But if you look in figure 3, one very interesting thing that I see in this figure is that of all the viruses that they tested, by far and away the most deficient virus in the CpG domain are the viruses that already express in our lungs as respiratory viruses. The common cold viruses and the respiratory viruses that are already endemic in the human population are the viruses that far and away have the fewest number of CpGs. And so what we have here then is a virus that's extremely resistant to the typical cellular machinery that would normally identify its genome as being foreign and eliminate it. And so then this guy makes the sort of circumstantial argument that this could be evidence that the intermediate host was a dog. Now, keeping in mind that none of the homologous viruses that have thus far been compared to this virus are canine viruses, and in fact we're looking at pangolins and bats, right, for the highest homology. And so the argument would still be that a particular bat virus, one particular bat virus with an extremely low CpG count, entered a dog population and then eventually jumped from the dogs after the CpG repeats were reduced. So it's like a weird chicken before the egg comes kind of argument, because he thinks, or he asserts, that somehow this is an indication of where this virus came from, but then we should be able to find the intermediate virus, right? Should be a dog somewhere in China. So maybe we'll find that piece, I don't know. But it doesn't feel right to me. The argument seems superfluous. And the thing that bothers me the most about it is enriching for a particularly low CpG virus would be something that anybody wanting to engineer a virus for virulence would know and select for, right? We know this is not like a secret. This paper is only telling you that the frequency of these sequences is very low in this virus. It's not telling you how that was generated, and it's not telling you new information about why that's important for the virus itself. It's correlated with virulence. The less of these repeats you have, the less potential places for the body or the cell machinery to identify the viral RNA as being foreign. And this paper also details another molecule that does some other things to RNA and could complement the zinc finger proteins in this process. Oops. But we're still in the same boat, because if you were going to engineer, or you were going to select for an extremely virulent coronavirus version, you would be looking for these sequences and selecting for viruses that were eliminating them. You could also imagine a scenario where you would select for the viruses, just as he describes, in a cell culture model or a animal model, a tissue model that was high in zinc finger proteins. So then you would select positively for viruses that have fewer of these repeats. So I don't necessarily think this is wonderful evidence for it coming from a dog, but it is wonderful evidence for it being a very virulent virus, and one of the reasons why we are not combating it as well, why the viral load may be very high in people before they're symptomatic, is because it's so efficient at avoiding the normal mechanisms that are in our cells. So that's an interesting paper. The next paper that I want to cover is a preprint by Knut Wittkowski. I'm now saying his name wrong. I'll get it right in a minute. I didn't write it down. But it's the guy that I gave you, Knut. The guy that I gave you in my previous video has alternative sources to try and encourage you to think beyond the mainstream media story about market origin and pandemic. And Knut really wants you to think hard about what he said in the beginning of that YouTube video. The whole YouTube video itself is frustratingly edited. But if you just paid attention to the first 5 or 10 minutes of that video where Knut's talking to you in front of a white wall, you basically get the idea of what this paper is about. This paper's got 15 figures, and he goes into detail discussing what he thinks, as an epidemiologist, has happened in the various countries that are reporting numbers. He does not mention anything about Chinese numbers and Korean numbers maybe being wrong. he makes the assumption that most of countries are not lying to us. So that could already be a big assumption that makes his conclusions kind of weak, but I don't think that's the case. What he does is he uses a very standard model for a respiratory virus infection in a population of 1 million, and then he discusses how when you choose to separate, when you choose to enact the social distancing measures, how that impacts the total number of people are infected, the total number of time, the length of time that you have to remain socially distanced, and the total number of people that die. And I think the main point of this paper is to simply show you that it's not as simple as closing the doors and closing the schools and then this is going to go away. And in fact, because it's loose, because we are not at the stage where we could contain it, that was already probably lost in January, then Knut would make the argument, as he did in his YouTube video, that the only way out of this in the immediate term is herd immunity, because a vaccine for a coronavirus doesn't exist, and it might not exist in 18 months. The idea that they're saying that it will exist is absurd, and anything that does exist will not be a vaccine per se, but it will be some kind of stopgap measure that's based roughly on vaccination biology, but likely is not going to be effective in the way that you think of a vaccine giving you immunity. And that's because of the history of SARS virus and SARS coronaviruses. We have not been able to make a vaccine for SARS, and it's not for want of trying. So Knut is suggesting again, as he did in the YouTube video and in this paper, that the best way forward is smart social distancing. Get off your phone and drive your car. So Knut looks at these various models, and what he sees when he looks at the models is that the time that you decide to initiate the social distancing, especially the closing of schools, has a huge impact on the outcome of the pandemic, of the epidemic. And in this case, what he's demonstrating is that if you do it too early, you actually avoid the first pass herd immunity, and you greatly extend the pandemic, and you kill more people. Now, these models are pretty independent of the hospitalizations, and it's not thinking about hospital overload. And so you got to take it with a grain of salt, but the biology is what he's trying to expound here. It's the biology. And the biology is really simple. There is no way around this, that herd immunity is reached fastest when the schools stay open and when we only protect the most vulnerable while trying to build up herd immunity in the rest of the population. And we didn't do that, right? We closed our schools too early. This is figure 14 and 15. And so then we've guaranteed ourselves a second bump. And not only have we guaranteed ourselves a second bump, but the second bump might be worse, because we have not started the process of herd immunity at all because we closed the schools. And he makes the argument in the video and in this paper that that's our main mistake, right? We closed the schools too early, and so the children didn't get it. And so we're not building up herd immunity until the children get it. So we don't have any real choice in the matter. Since we started like this now, we're kind of screwed. And it's very much screwed in the middle of the country, should we get something like that in Pittsburgh, for example. If all of our children haven't gotten it yet, and only a few of our adults have gotten it yet, then we're never going to get herd immunity until we reopen the schools. And when we reopen the schools, the herd immunity will also require old people to get it. And those old people are still going to die, because it's not about overload, right? Overload's a separate part of the death toll. There is a first biological death toll that just has to do with how deadly is the virus. And so in this paper, Knut also makes the argument that with perfect action, perfectly timed social distancing, at most, we could mitigate about 10% of the total deaths. It's about all we can do. That's a pretty stark contrast to the sort of imaginary game we're playing now, where we're trying to pretend that we can save lots of people if we flatten the curve. And what Knut is making the argument for is that's not the case. Actually, flattening the curve may result in more people dying. And in some places it might mean that we don't overload the healthcare system, but the healthcare system was never going to be overloaded by children, you see? And that's the mistake we're making. We should have isolated the old people and kept the schools going. We'd lose some teachers, probably, but we're going to lose people, man. And I understand that there are the mayors and governors have to have a sort of no losses acceptable kind of attitude, but that's not really realistic. Because it's a biological certainty that we're going to lose people. It's biologically certain that we're going to lose people from flu every year. It's biologically certain. So yeah, this is a very interesting paper, I think, because it's Knut putting his money where his mouth is, and I like that. But it's a preprint, so there are text errors and it's not written the best. But I like the fact that he put this paper out to kind of back up what he was saying in those videos. So check these two papers out, add them to your list of stuff you know, and let's keep attention peaked, keep our eyes on the ball. Peace out, folks. Hoe is het met je? Groot dikzak in dikzak. Hoe is het met je? Groot ding. Hey guys, thanks for joining me on my ride. This ride will cover two papers. One paper that's been circulating in social media lately, which seems to indicate that dogs may be the zoonotic source for the SARS-CoV-2 virus. I don't necessarily think that that's a good interpretation of this paper. It is mentioned in the discussion, but the primary observation is that the current SARS-CoV-2 virus has an extremely low level of CpG dinucleotide sequences, and these are sequences that are targeted by zinc proteins, zinc finger proteins, ZAP proteins in your body to prevent or to degrade them. So essentially they are part of the natural indicator for our body that viral genomes are there and that we need to eliminate them, especially RNA. Interestingly enough, the two viruses that are endemic to the human population that they sequence, the HKU coronavirus and the OC53 or something like that, these two viruses which are known to circulate in the human population and cause respiratory problems, these two viruses are also extremely low in these CpG repeats. So it's an interesting observation, but I'm not really convinced that this necessarily definitively shows that a bat interacted with a dog and then it evolved in a dog and then eventually it passed to humans. I think that's still a pretty far cry from parsimony, and in terms of Occam's razor, I don't think that's the easiest explanation for the existence of this virus, but it does give us some insight into viral function and gives us insight into thinking in terms of how you might weaken a virus to make a vaccine or strengthen a virus to make it more virulent. And so you could see this as just a new piece of data nice to put in our current concept of what's going on. The second paper that I cover is a preprint from Knut Wittkowski, the guy that I shared a YouTube video from, where he was basically saying that the only way out of this is herd immunity, and that we're making a big mistake by doing this extreme social distancing, and that it will only delay a second peak and maybe even increase the number of people that die. It's a 15-figure paper that looks at the responses in different countries around the world and tries to make some correlation between the time at which they reached their peak, the time at which they enacted social measures, and the sort of progress that the epidemic made in those individual countries. And he cites the fact that the United States closed very early, and what this means for us could be that we've actually delayed the peak and delayed the formation of herd immunity. And the main thing that I think he's critiquing is that we closed the schools too early, because the schools are really where this herd immunity is formed the fastest, and so we needed the kids to get sick. We should have probably put the old people and those that are most vulnerable to the infection in quarantine or social isolation, but we shouldn't have social isolated the kids, because now what we've done is basically delayed the actual peak that's coming. If he's right about this, then we have a long time to go, and there's going to be a lot of economic pain to come, because even if we reopen, what will end up happening is that the outbreak will be worse, the results will be worse, and we're going to have to close again. So read the paper, digest it, just use it to help you think as you move forward. Again, it's not a definitive result. Neither of them are definitive results, but they are papers which I think start to help us think deeper about what the coronavirus and what we're experiencing. If you liked it, like and subscribe, and I'll see you next time on JC on a Bike.